Okay, so at the start of the notes, we are just taking x plus y to consecutive powers, increasing powers. So we did anything to 0 power is 1. To the first power is itself. To the second power, we maybe used FOIL, or you used a grid. Now combine like terms to get the third one. The second one, sorry. I am going to multiply out the third power right now. I could do a grid. You don't have to use a grid. You can use just distributive property. Okay, when I do this, and if you do the distributive property instead, you will have some like terms. Even though the y is out of order, we can arrange the order. So we'll have some like terms. We're going to combine our like terms. And for the third power, we will get x cubed plus 3x squared y plus 3xy squared plus y to the third.
I put that.
No, you had like,
I had this.
you didn't have 4 terms when I looked at yours.
I had these, and there was a gap in the middle.
There was a big gap in the middle. Oh, maybe I looked at only part of it then, dear. If there was a big gap in the middle, maybe that's what happened. Okay, so then you're going to do the fourth power. So we're going to come over here and we're going to either use distributive property or make a grid. That's totally up to you. Something that I'm going to notice every single time is that it's going to start with x to the fourth. It's going to end with y to the fourth. That's kind of a pattern that we're going to start picking up on patterns. Let's see, 3x to the third y, 3x to the second y squared, and then xy to the third, x to the third y, 3x squared y squared, 3 xy to the third. And then we look at our like terms, which are diagonal from each other. And we combine our like terms. X to the fourth plus 4x to the third y plus 6 x to the second y to the second plus 4 xy to the third plus y to the fourth. You make sure you have those written down. And then we are going to look for patterns. John, is there any sort of pattern that you would see? Any sort of pattern that you see on all of these?
The middle terms. It's like one middle term and then 2, and 4x to the third y plus 6x to the second y to the second. And then
So what do you notice about the middle term?
like when it's squared, there's only 1. When it's cubed, there's 2, and then the fourth power is there's 3.
Oh, so you're saying like in between the x to the fourth and the y to the fourth, that's increasing? Is that what you're saying?
Also,
okay.
X's and Y's at the end of like the correct power.
Okay. So John's saying at the beginning and the end, we've got x to that given power or y to that given power. And then he's saying in the middle, when there's squared, there's 1 middle term. When there's cubed, there's 2 middle terms. When there's fourth, there's 3 middle terms. So that's a pattern that John noticed. Chris, do you see any patterns? 0 patterns. Mm-hmm.
I mean, we've already listed the ones on the end. They both look the same.
Okay, so you saw that. Here's what the question is. What would x plus y to the 5th look like without us actually multiplying it out? Let's use what we see here in the patterns, and let's try to figure out what it would look like. And then I'm going to come back to looking at just the coefficients. Okay? But let's try to figure something out about x plus y to the 5th. Anthony, what's something about x plus y to the 5th that I could definitely put down? It's going to start with x to the 5th, and it's going to end with y to the 5th. Excellent. What's something else that we can tell? Lena? There's going to be 4 middle terms. Okay. So we'll have plus 1, plus 2, plus 3, plus 4 middle terms. Okay. Now I'm going to erase those little blanks because that's me just trying to make space for it. What else? Besides something I haven't taught yet. Caleb, you got something?
The coefficients are going to be 5, 10, 10, 5.
Okay, so I'm going to, for sure, put down that the coefficient here is going to be 5. Can you guys tell when you look at the other ones? Look at this coefficient. We didn't talk about coefficients yet. So when you look at these, I'm going to highlight. When you look at the coefficients, we've got a 2 on this one. Oh, why did I pick that color? Got a 2 here. We've got 3s here. For the 4, we've got 4s. It's like that middle is 2. The 2 middles are 3. Then it's not the middle, but it's the 4s, kind of like, it's the second term in from the ends. Is the same number that the power is. This is for real a thing. That's going to happen every single time. Okay, I don't want to know anything about the coefficients yet. I want you to just look at the variables. Like, look at the x's on x to the 3rd and x to the 4th on those. Look at the x's. No? You're shaking your head.
It goes 3, 2, 1.
They start with 4, then it goes 3, then it goes 2, then it goes 1, then it goes 0. Or the 3rd, yes. Like, they're decreasing. That happened on every single one of those. So if I ask you to do the 5th, well, we know it's going to start with x to the 5th. What's the next one going to have? X to the, whoops. Next going to have x to the 4th. Then x to the 3rd. I don't know what the number in front is. Then x to the 2nd. Then x to the 1st. And then we end with no x's. Is there a pattern with the y's? The y's are increasing. We start with 0 y's, 1 y, y to the 2nd, y to the 3rd, y to the 4th. So they're going up. So I can do that right here. If I know if I end with y to the 5th, then I'm going to have y to the 4th here. I'm going to have y to the 3rd here. I'm going to have y to the 2nd here, y to the 1st, and then no y's to begin with. So boom, 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 I can just write those. So then the last thing is the coefficients. And some people learned this last year. I know that my class didn't do it last year. So I'm going to look at only the coefficients for each of these. For the 0 power, the coefficient is 1. For the first power, the coefficients are 1 and 1. X plus y, 1 and 1. For the second power, it's 1, 2, 1. For the 3rd, it's 1, 3, 3, 1. So far we're using 1, and then we're using second power 2, we're using third power 3. Fourth power is 1, 4, 6, 4, 1. So we have the 1s on the outside, we have the 4s next, but then the 6 comes from somewhere I'll show you in a moment. So the 5th we haven't done yet is going to start with 1, 5, and it's going to end with 5, 1. Now, Caleb learned this before. Am I correct, Caleb? Yes, Caleb learned this before because he already told me the answers are 10. The next line is going to be 1, 6. It's going to be 15, 20, 15, 6, 1. If you haven't seen this before, I am getting 20 by looking at the two numbers right above it and adding them together. I am getting 6 by looking at the two numbers right above the 6 and adding them together. I'm getting the 1 by looking at the two numbers right above it and adding those together because there's nothing on the outside. So to get any of these numbers, once you have the first couple rows, you just add the two numbers above it and you get the number that goes underneath. This right here is called Pascal's triangle. This is called Pascal's triangle. So I have what do you notice about the exponents? We talked about it. I didn't actually write anything down, but instead in this space, if I wanted you to create x plus y to the 7th, and it is not created yet, could you see right now if you could do it? The coefficients, oh, I forgot to write the coefficients in this one. These are 10s. The coefficients are coming from Pascal's triangle. The variable exponents, we just discussed patterns. So can you try x plus y to the 7th without multiplying it out? Just using patterns, try to write that down. Without multiplying it out, try to write it down. So I didn't write the 7th row in the Pascal's triangle. You have to do that yourself too. So as you're filling this out, there's one thing that nobody really said about patterns. John kind of said it, but I'm going to word it a little bit different. You know how John talked about the middle terms? I'm just going to talk about the total number of terms. When we had a power of 0, the number of terms was 1. When we had a power of 1, the number of terms was 2. When we had a power of 2, we had 3 terms. We had a power of 3, we had 4 terms. So how many terms am I going to have for a power of 7? Not 6. How many terms, if my power is 7, like I'm doing down here? I'm going to have one more. So the power plus 1 equals the number of terms that you will have. So I'm going to have 8 total terms. One, two, three, four, 5, 6, 7, 8. So I've got space for 8 terms. Okay. Then I'm going to go to my Pascal's triangle, and I was like running out of space, but it'll be 1, 7. It'll end with 7, 1. To get anything in the middle, we have to add the 2 numbers above it. So 6 plus 15 is 21. 15 and 20 is 35. 35, 21. So those are all my coefficients. 1, 7, 21, 35, 35, 21, 7, and then 1. Then I just have to put my powers. So x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and then 0 x's. Then we've got 0 y's, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, y to the 5th, y to the 6th, y to the 7th. And then we're done. This is the start of section 9.5, which for juniors, that'll be like the last stuff that we have on our test when we have it in like 2 weeks or less than 2 weeks. We're just going to take what we went over here with Pascal's triangle and just do it with like more complicated binomials, not just x plus y. That's really the only other thing that we have, kind of, for the most part, that we'll learn next time. So remember, next time we have a quiz on 9.1, 9.2, 9.3. And do the review, check your answers. Make sure you have, if you have questions, you come see me in XH or you send me messages so that you're ready for that quiz. Everybody's taking the quiz. Just not everybody's taking the test.